Program E-belajau Additional Mathematics Form 4, Chapter 5, Progressions. I am Madam Lau Mei Hua from SMK Gajah Berang. So today we are going to learn 5.1 Arithmetic Progression and the Learning Standard 5.1.1 Identifying Arithmetic Progression and 5.1.2 Deriving the formula of the n term Tn of arithmetic progression. Okay, 5.1.1 Identifying arithmetic progression. Okay, inquiry 1. So the aim is to understand arithmetic progressions. Okay, instruction are, okay, 1. Observe the following polygons in which the number of sides of the consecutive polygons increase by 1. Okay, 2. Divide each polygon into triangular shape as shown in B and C. So you can see diagram B can divide into 2 triangular shapes, and your diagram C you can divide into 3 triangular shapes. Okay, number 3, in the table, fill in the sum of interior angles for each of the given polygon. Okay, when n equal to 1, the sum of interior angles is 180 degrees because the sum of the interior angles of triangle is 180 degrees. When n equal to 2, there are 2 triangular shapes. So it's 180 degrees times 2, so become 360 degrees. When n equal to 3, is 3 times 180 degrees, which is 540 degrees. And when n equal to 4, is 4 times 180 degrees, so the answer is 720 degrees. When n equal to 5, so n times 180 degrees, so the answer is 900 degrees. When n equal to 6 is 6 times 180 degrees, become 1080 degrees. Okay, the sum of interior angles for each of given polygon can be written in the progression of 180 degrees, 360 degrees, 540 degrees, 720 degrees, 900 degrees, and 1080 degrees. So your 180 degrees, 360 degrees, 540 degrees, 720 degrees, and so on is a finite sequence that follows a specific pattern. So each number in the sequence is known as term. So such that the first term is written as T1, second term T2, and so on until Tn. So which is the n term. The difference between any two consecutive terms of a sequence is a fixed constant. The constant is known as common difference and it is represented by D. So D is equals to T2 minus T1 equal to T3 minus T2 and equal to Tn minus Tn minus 1. Arithmetic progression is a sequence of numbers such that each term is obtained by adding a constant to the term before it. Okay, now here are some of the examples how to determine the given sequence is an arithmetic progression. Okay, so look at example 1. Determine whether each of the following sequence is an arithmetic progression. Give your justification. Okay, A, 358, 350, and 342. Okay, so your D1 is T2 minus D1. So 350 minus 358, so answer is negative 8. So D2 is T3 minus D2. So 342 minus 350, so answer is negative 8. So this sequence is an arithmetic progression because D1 equal to D2 equal to negative 8. Okay, B, you are given the sequence is 2 over 3 2, 10 over 3, and 5. Okay, so again you find your D1. D1 is T2 minus D1. So answer is 4 over 3. D2 is T3 minus D2. So it's 10 over 3 minus 2. Answer is 4 over 3. Okay, your D3 is T4 minus T3. So 5 minus 10 over 3 is 5 over 3. Okay, now this sequence is not an arithmetic progression because your D1 equal to D2 but not equal to D3. Okay, now look at example 2. An auditorium has 15 chairs in the first row, 19 chairs in the second row, 23 chairs in the third row, and so on. So determine whether the arrangement of chairs in each row follows arithmetic progression. Okay, give your justification. Okay, so the solution is, okay, so you are given the sequence is 15, 19, 23, and so on. So you find your D1. So it's 19 minus 15. Okay, so answer is 4. Your D2 is 23 minus 19. So answer also 4. So this means, okay, so this means since the difference of the progression is a fixed constant, okay, so the arrangement of chairs in each row is in the auditorium follows an arithmetic progression. Okay, now we go to 5.1.2, deriving the formula of the n term of arithmetic progression. Okay, so inquiry 2. So the aim is to derive the formula of the n term, Tn of arithmetic progression. So the instructions. Okay, 1. Okay, consider an arithmetic progression 2, 5, 8, 11, 14, and so on. Use the pattern of this sequence to complete the table. Okay, assume the first term of an arithmetic progression is A and the common difference is D. Okay, now complete the table below. So the first term is 2, isn't it? Okay, so the method to obtain the value of term, so here does not have D, so start with 2. So your formula by deduction method, so T1 is A plus 0 times D. Okay, when go to T2, second term, so 5 equals to 2 plus 3. So you add your D at T1 term. This means is 2 plus 3. So 2 is first term, D is 3. So this means the formula, so is T2 is A plus 1 times D. Okay, when go to T3, 8, 8 is equal to 2 plus 3 plus 3. This means add D at second term. Okay, so this means T3 is A plus 2D. So we can complete the table. And then from the result of inquiry 2, so the n term of an arithmetic progression can be written as Tn equals to A plus m minus 1, okay, in bracket times D. Okay, such that A is the first term, D is the common difference, and n is the number of terms. Okay, now we go through some of the examples. Okay, now is example 3. Find the 15th term for the arithmetic progression -4, 2, 8, and so on. Okay, so here A is -4. Okay, you have to find your D first. Okay, D is D2 minus D1. Okay, 2 minus -4. So here your D is 6. Okay, this means we want to find 15th term, T15, by using formula A plus 14 times D because n minus 1. Okay, okay, so answer is 80. Okay, example 4. Okay, given that an arithmetic progression with the first term is -6, the common difference is 11, and the n term is 126. Find the value of n. Okay, the solution. Okay, A is negative 6, so you write down the given information. D is 11, so Tn is 126. Okay, so by using formula of Tn, okay, so you substitute Tn with 126. A is negative 6, so your D is 11. So you can find your N. So N is 13. Okay, the next example. Okay, find the number of terms of the arithmetic progression. Okay, so 1 over 4, 1 and 1 over 2, 2 and 2, 3 over 4. And the last term here is 9. Okay, the solution, okay, Tn is your 9. Okay, okay, D is, okay, you can use T2 minus T1. So 1 and 1 over 2 minus 1 over 4, answer 5 over 4. So by using formula, A plus N minus 1 times D equal to 9. So substitute A with 1 over 4. Okay, so your D is 5 over 4. And the Tn is 9. So you can find your N. Okay, so your N is 8. Okay, example 6. If 2x, 4x plus 1, and 14 are three consecutive terms of an arithmetic progression, find the value of x. So this means your first term is 2x, here second term is 4x plus 1. Okay, 14 is T3, let's say. Okay, so the solution, this means we use the T2 minus T1 equal to T3 minus T2. So the D are the same. Okay, so this means 4x plus 1 minus the first term 2x equals to 14 minus, okay, the second term 4x plus 1. Okay, so you solve the equation, then you can find your x equal to 2. Okay, now example 7. In an arithmetic progression, the third term is negative 12 and the fifth term is negative 22. Find, okay, part A, the first term and the common difference. B, the 12th term. Okay, so T3, third term is negative 12. So by using formula, T3 is A plus 2D equal to negative 12. Okay, so the T5 equal to negative 22. So it's A plus 4D equal to negative 22. So you solve the two simultaneous equation. So it's 2D equal to negative 10. So D is negative 5. Okay, so you can find your A. So A is negative 12 minus 2 times negative 5. So A is negative 2. Okay, so this is the first equation. This is the second equation by solving the simultaneous equation. So you can find your D first. D is negative 5 and A is negative 2. And then part B, okay, T12 is A plus 11D. So it's negative 2 plus 11 times negative 5. So your answer negative 57. Okay, that's all for today. Thank you.